Let's take a look at number 3. Here we got another multi-part question here. Notice we have an A, like how many moles are required to react with this much of that particular reactant. Then we're asked, what is the limiting reactant? Right, that's a pretty standard question. Then how many grams of water will be formed in this reaction? Okay, and so these are archetypes that you will most certainly see on the quiz. Now, one thing you might not be familiar with is neutralization. Okay, this is an acid-base reaction. Acid-base reaction. You don't have to know what that is. All you have to know, truly, you do not have to know what that means. You just need to know that these two neutralize each other. For every one of these, I need 2 of those in order to carry out this neutralization reaction. Again, you don't have to know anything about neutralization. You really don't. You just need to know there's a 1-to-2 ratio in order to get this reaction to progress. That is all you need to know. Again, don't focus on the things that you don't know. Use the skills that you do have, because that's what we're practicing here. So again, these are our 2 amounts. And just, by the way, I'm noticing 2 significant figures and 2 significant figures. So when I go to report some final answers, I'm going to use 2 significant figures in my answers. First up, how many moles of HCl are required to neutralize all 0.05 moles of the calcium hydroxide? Okay, so I know that I'm given moles of calcium hydroxide. I want to know how many moles of HCl it takes to react with this amount. Simply convert from that particular reactant, right, the given, which is the term your book uses, into moles. Again, they're asking for moles of the unknown. Plug in some numbers. Actually, let me show you that those cancel. Plug in some numbers. We start with 0.050 moles. We have 2 moles of HCl for every 1 mole of calcium hydroxide. And we see that, again, you can either do this in your head or bust out a calculator if you are so inclined. Again, 2 significant figures. You need 0.10 moles of HCl in order to completely react with this given amount. Okay, so box that out. Make sure we do that. Moving on to part B. What is the limiting reactant in this neutralization reaction? Well, here, we've actually already done some of the calculation that will allow us to figure this out. Again, follow this thought process. We have 0.05 moles of calcium hydroxide, one of the reactants. We have 0.05 moles of it. Okay? And we have 0.08 moles of the other reactant, HCl. All right, you guys see the connection here? So, how much HCl, according to part A, how much HCl do I need to fully react with this given amount of the first reactant? 0.10 moles. Do I have 0.10 moles? No, I do not. I do not have that much. I have less. I have 0.02 less. So that means I do not have enough HCl to react with this much calcium hydroxide. I don't have enough, meaning this will be limiting. This will be limiting. HCl will be limiting. Well, because I like to focus on repeatability, if that process doesn't jive with you, let's go back to our old school setting up 2 different stoichiometric calculations, right? There's no problem with that. So I'm going to start with 0.05 moles of my first reactant as per the question, and I'll convert out of that into one of the products. Now, truly, it does not matter which one of these products you convert into. Just make sure that you convert both of the reactants into the same product, right? That is key. Here, I'll just pick H2O. It has a calming effect on me for some reason. I don't know why. 0.080 moles of HCl. I'm going to convert out of moles of HCl and into moles of, again, making sure it's the same product, H2O. Units for the reactants cancel, and both reactants will be converted into moles of H2O. Again, it has to be the same product. You can't compare apples and oranges. You got to compare apples to apples and oranges to oranges. So the mole ratio for calcium hydroxide to water is 1 to 2. Mole ratio of HCl to water is 2 to 2. And let's do some calculations here. Now, if you notice, this is actually the same calculation. This first calculation is the exact same thing I did in part A. I'm just doing this for completeness sake. And this bad boy right here will come out to be 0.08. Let's see. Nope, I did not do that right. Holy cow. I was starting to freak out. Goodness gracious, that's so atrocious. I need some whiteout. Oh my gosh, don't look at this, kids. Oh gosh. Alright, so this is what happens when you try to do stuff in your head. Even though that is a simple multiplication, I mess that up in my head. Okay? I'm not going to do that again. Come here, calculator. Help me out. Let me make sure that I'm doing this right. 0.05 times 2. Haha, yeah, that would have really messed me up. Okay. Now, looking at these two amounts, you can tell that that's the smaller amount. This is less product. So that means that the HCl is producing less product. So HCl is limiting. Part C, how many grams of water will form from this reaction? Now again, all we're going to end up doing is the factor label method of dimensional analysis. That's not going to change. What I want you to do is realize what this question is asking of you. How many grams of water, right? According to this chemical equation up here, we know that HCl is limiting, meaning all this 0.08 moles will be consumed. So that allows me to start in the moles of HCl, convert out of moles of HCl, and into moles of what's being asked for, right? The water right there, H2O. But this question is asking for grams, so I'm going to have to do one more conversion factor using the molar mass of water to generate the unit that this question is asking for. So, again, now I'm ready to plug in my numbers because everything will cancel appropriately. I start with my 0.08 moles of HCl. My ratio of HCl to H2O is 2 to 2. And water ends up being, I'm just going to stick to two significant figures here. If you were to add this all up, it ended up being 18.02. We'll go 18 grams per 1 mole. And let's see. Again, I already messed up an easy multiplication. Let's not do that again. Let's bring the calculator into it. I'll go times 2 divided by 2 just for completeness sake. And then I'm going to multiply by 18. Excuse me. Now again, appropriate significant figures, that's 1.44. I'm only using two significant figures here because, again, the question gave me numbers that had two significant figures to start with. So I'm actually going to report 1.4 grams of H2O as my final answer.